Hi, this is Nalini Elkins with Industry Network Technology Council. We are recording this session. Yes, I'm getting some notes that the sound is good. Thank you so much. If you have any problems, do please let us know. This session is on IPv6 transition technologies. This is the lab portion, as we do. It will be presented by Mike Ackerman of Blue Cross of Michigan. As many of you know, this is a joint project with the India Internet Engineering Society and Industry Network Technology Council, both nonprofits, with funding from ISIF Asia. There is another portion which is funded by Aaron, and thank you so much to both organizations. It is a multi-year collaborative project to provide training, security, and application analysis, and those are two of the biggest problem areas we foresee in IPv6. The end point, of course, is to help enterprises plan deployment of IPv6. So we've done quite a few sessions so far. I just did the IPv6 transition mechanisms last week, and now you have the pleasure of having Mike Ackerman do the lab portion. Mike, as many of you know, is responsible for much of the planning, deployment, and administration for the Blue Cross of Michigan network, a very large network spanning one of our biggest Blue Cross areas. Mike is chief architect for networking issues. I've had the pleasure of working with him for over, 15 years now. We've co-authored a number of RFCs and are working more. So without further ado, let me turn it over to Mike. Thank you so much, Mike.
Thanks so much, Nalini, and hello and good morning, everyone, or good afternoon or good evening, no matter wherever you might be. So here's our agenda. We're going to approach this from the consternation of having to have the reality settle in that we're actually really going to deploy IPv6, and oh my God, what am I going to do now? And the focuses of today will be on the challenges of coexisting with IPv4 and IPv6. The most of the time we're going to spend in the bold print here is on some use cases, and we're going to try to do a live lab. Yes, I'm still crazy. And then we'll just wrap it up with some conclusions, questions, and comments. And unlike, I think we're going to finish on time or even early, so we should have time for lots of questions and comments, and maybe even cover some other things. And Nalini, I think as always, you'll be monitoring the chat to see if we have any questions that we want to take during the presentation. Is that still true?
Yes, of course. Please go ahead and send questions into the questions window, and as appropriate, we will cover them when Mike takes a break, or else we'll get to them at the end.
Sounds good. Okay, let's go on to the next slide. And that will be, yes, oh my gosh, we are going to deploy IPv6. What do we do now? And I think a lot of us are like because Nalini makes it look so easy when she's telling us all these things and how to do it. Well, actually, even then it's not so easy, but understandable. And then when it comes time to do it yourself, it takes on a whole different meaning or perspective. That's where we're at right now. We're really going to do this, and what are some of the challenges? So on to the next slide. And the focus challenge of today is, how do we support all that we have today, which is unfortunately our priority, deploy IPv6 and still coexist with all the IPv4 that we have out there. So that's what we're going to really be covering today. And on to the next slide. And this is a slide I stole from Nalini last week, so if it looks familiar, that's the reason why. Just depicting what does it look like today and what will it look like tomorrow. And it's quite a bit different. You know, today's pretty simple. We just have one address usually. And now tomorrow we're going to have all these other IPv6 addresses, which we've covered, which we understand now, but it's a little bit more complex. And we're depicting dual stack here. We could even be going to IPv6 only. Mike's opinion is that's probably not going to happen in too many situations, but there may be some where it makes sense to try to get down to just the one stack. Smaller devices, maybe you want to simplify your management, and we're going to cover some things today that'll show you why you might want to get there as quickly as possible. I think that's all on that, Nalini. On the next slide, so the things that we need to be concerned about, the things that we're going to try to cover today, are the top challenges of these two protocols existing together. And here's some of them that I thought of. There's more, but the technical expertise that we have to develop in both protocols, so all of us should get double our salaries, right? Okay, and then we need to manage these dual stack networks on all the devices, and we're going to have a lot of them, and we already do, and there'll be even more. The next bullet is security. Security remains important, and it's probably going to be even more important now, and there's going to be more that we need to attend to, just what we wanted to hear, right? But I'm afraid that's the truth, and one of our cases will talk about security. There's obviously, as we've already seen, there's going to be added complexity and overhead, but thanks to Nalini, we can handle that, right? And obviously, there's many more addresses and routes, way, way more. Next slide. We want to do all that while maintaining or even improving our performance. And of course, our number one edict is that we can't we have to minimize the impact on production, no problems. That's what we hear all the time, isn't it? And keep in mind in the bold print here that we have to keep in mind that these two protocols can't talk to each other. They have to be managed separately. So keep that in mind all the time as we're approaching all these issues. So, deep breath on my part. How do we decide the best coexistence technologies and methods? And that will depend largely on what our use cases are. So we kind of have to examine those. That's not that hard to figure out. We'll figure out what we need to do. And what we're going to do today is we're going to try to show live examples of that. Yes, we're going to be risky here and do this all live. All the information's in the slides, I think, but I've always felt that showing this live, although risky, is the best way to really kind of hammer at home what we actually need to do. So there's going to be a bunch of examples and commands and definitions. And I think that's all of that. Next slide. And this is another slide I stole from Nalini's presentation last week. This just lists the technologies. She went over them last week. So the issue is that there's a bunch of them, and gosh, what do they all mean, and which one should I use? So let's go on to the next slide, which basically articulates that question. Which one should we use? And as I said a moment ago, it's very use case and situation dependent. We kind of need to figure that out as we go along. And for now, let's try to figure that out and show some examples by modeling this in our lab. So it is lab time, hooray. And we're going to have 3 coexistence use cases in our lab. And we're going to try to show some of the things that will happen in your network. Now, remember, when I pick these use cases, I'm thinking this is what most enterprises are going to experience. This is what they need to deal with. There's going to be a whole bunch of other use cases. And maybe if we have time, we can even talk about some at the end. So Nalini, let's go right into what the use cases are. And the first 2 will focus on hosts. And the first use case is you have hosts that need to have sessions with other hosts, clients or servers, and you don't know. Those other hosts could be IPv4, they could be v6, or they could be both, which means they're dual stack. And we don't want to have any of these problems with any of these sessions that they're IP layer related. So what I'm saying is in that situation, which is a pretty normal situation, pretty normal use case, let's use dual stack. So the first lab session we'll do dual stack, and we'll show how that might work. And the second case is, let's say that we do progress, we have IPv6 and we have some IPv6 only hosts for whatever reason, and they need to have sessions with IPv6 servers. That's fine, they can talk together, but as we said, the 2 protocols don't talk. What if I need to talk to an IPv4 only server, and there are a bunch of them out there? They could be your servers, they could be servers on the internet, and so how would we do that? And my suggestion here is, and what we're going to model in the lab, is to use NAT 6.4, and we'll talk about what that is and how it works. And on to the next use case, which is security, as I promised or threatened, I guess is the case. And the point here is that not everything, when you have IPv6 to maintain in your network, not everything is going to be an IP layer issue. Security is still big, and arguably it's going to be even bigger as our networks grow. We have multiple protocols now. Things are not getting simpler, they're getting more complex. So security remains an important topic. So we're going to cover something there. Next slide, Nalini, please. The third use case is on security. And obviously there's a bunch of different security functions and platforms. We're going to focus on firewalls for now. We're going to talk about rules and some of the things that we probably need to consider as we try to maintain a dual stack environment. So let's go right into the first case. Now, Nalini, can I share and start showing that?
Yes, 1 minute. Yep. Hang on for 1 second. I'm going to make you present, so then you can show your stuff.
Okay, so I don't need to do anything other than click on what you just did for me. So that's good. Hooray. And am I sharing now?
Yes, you are.
Right, it's working. One logistical question that I have for everybody. Please give Nalini feedback. I'm obviously showing a Windows CLI screen. I think I can see it okay. Let me know how it's coming through on slides over the presentation, over the webinar here. There are things we can probably do if it's not looking good, like reverse the font or make it bigger, but this is kind of the generic look at it. So with that, we're going to go right into the lab here. And again, this is case number 1, and that's where you have hosts that need to have sessions with other hosts that you don't know whether they're v6, v4, or they're both. So let's take a look and see what we look like first. And the first thing we're going to do is that we're going to look at an IP config, and this is going to be similar to what we showed before. And we're looking to see, are we dual stack or what are we? So let's take a look here. Yeah, we got a whole bunch of IPv6 stuff, it looks like, and we do have an IPv4 address, so we are dual stack. So hooray for us. We can also do, the all command and get a little bit more information. That extends things like the default routes and DNS and things, but we're still dual stack. So let's see, and I'm gonna
Mike, I'm gonna interrupt you just for a second, because I am getting some people saying, can you increase, you know what? So guys, I'm just thinking, yeah, if you can, I don't know if you have a way to increase the font. What I'm really thinking is that when we go back to the slide part, or else people, guys, if everybody who's listening, if you make the thing full screen, then it'll come in a little bigger. I think it's going to be a little hard for me to interrupt Mike right now. Sorry, I mean, I already did interrupt you to make it.
Yeah, too late. The damage is done. No, and I should have been more clear. If we're going to do larger font, reverse font, or anything, different colors, which we have explored with a couple other people, and they decided that this was good enough. But if the consensus is we want to do something different that might be more readable, that would be for next time. I don't think we want to try to do that right now. So
okay.
Apologies if I misled anybody. So get out your magnifying glasses, and we'll hope for the best. And like Nalini said, when we go back to the slides have listed all the commands that I'm going to issue. What they won't see, obviously, is the responses to the commands. So hopefully you can capture that, and it'll be in the it'll be in the recording. So if you view the recording, you can get your magnifying glass out for that, I guess. And once again, we'll do better next time if that's what it takes. So I'm gonna issue one more command here, and basically it's just to show how many active sessions I got there. And there really isn't much going on, is there? And the one thing that is going on, by the way, is an IPv6 session there, other than a couple loopback things that don't really matter. And if you see what port that is, that's Windows RDP. That's me. So I'm coming to you live over IPv6. So that's pretty cool too. So what we're going to do next is we're going to try Google Chrome, and we're going to try a session with Google and see if it works. So let's see what that can possibly do. So I'm clicking on it, up it comes, and it looks like it worked, and we have a session with Google. So yay. So let's go back over here and take a look. Do the same command. And yep, there's a whole bunch of new sessions that Google has established for us. And yeah, and it worked. I might also add, and I'll probably say this a few times, you notice all the sessions are IPv6. And if you look at the from and to address, they're both IPv6. You know, this one's our server, and then these are Google and a couple other things Google has spawned us off to. So you'll never see a v4 on this side and a v6 on this side, or vice versa. So again, they're separate. They don't talk to each other, and that's just the way it works. So that is it on that. I'm going to go back to the web session, and I'm going to kill Chrome. No, I'm not. There. And now let's take a look at our sessions again with, and for anyone that can't see it, I'm doing a netstat command. And so we're back to kind of having nothing left. And so we're all back to where we needed to be. And so let's go on a little bit further in our case one, which is dual stack. We've now established an IPv6 session with Google using Chrome. But let's see if we can find an IPv4 only server. So to do that, I'm going to do a command, and I'm going to see if wiki.com. So wiki.com has an address of 66.96.149.1. So wiki is IPv4 only. So let's see if we can get something with them. And you know what? I want to do something while we're here. Just a contrast to give it a little bit more meaning. So we can see down here, wiki.com is the name, and there's his address. How would it look if there was a v4, v6 host, or a dual stack host? Let's look at Google. They are one. And look, they have two addresses here. One is v6 and one is v4. Just for one more example. So that's just contrast as how they look if you do a DNS display of them. Let's see what Facebook looks like. Well, you might have demoed this last week, so maybe this is extraneous, but I always think it's cool. So Facebook has both as well, but Facebook spells out sort of their name and their IP address. So it just shows the flexibility that you have with these big addresses and the things that you can do with them. That was last week's session, so I won't belabor that. But it is important. It is something that you can take advantage of if you want to. So we've now determined that wiki, back on track here, Mike. That wiki is v4 only. Let's go over and see if we can get there. And we already are there. Let's clear the screen and establish another session. So yeah, wiki. We are getting to wiki. Let's see if indeed that did occur over. We're going to do our netstat display of active sessions again. And look, we got a new one at the top here. And that is, this is our IPv4 address that we saw in our IPv config display. And there's that 6696 thing. We indeed have a session with wiki.com. So that is kind of the end of case one. I'm going to pause now and see if there's any questions that we want to cover right now. Nalini, that's up to you.
Yeah, I think that looks great. Shall we go back to the presentation?
We can do that, or I can go back. I can go right on to case 2, whatever you want.
No, why don't, yeah, that way we don't have to go back and forth. Why don't you go ahead and go to case 2 then? Maybe explain.
It might be a good idea. Let me do the cases, and then we'll go back, several slides and start with case 1 and just kind of go over what we just did. Sure. So let me just talk it out now. So case 2 is the situation where, let's say we've upgraded to IPv6. We are dual stack in our network, but we have some hosts, for whatever reason, that are IPv6 only. And that's really not a bad idea, because now those hosts only have to support one protocol. So especially for smaller hosts, or just to simplify your environment, that's not a bad idea. And a lot of folks that have converted to v6 say, oh yeah, now we want to be v6 only for those reasons. You may even have other reasons, like the hosts may be small, they may be IoT devices, they may be lacking memory, etc. And maybe it's a necessity to get down to that level. So it's not an unrealistic scenario, and that's why I came up with that as case number 2. So let's start out with that, and we'll take a look. We kind of already know this because we haven't really made any stack changes, but how does our system look from the IP config standpoint? And we still have our v4 addresses, several v6 addresses. Everything looks good. Everything looks wonderful. We already know about wiki.com, which we're going to use in this example as well. So he's still just a v4 only server. And so now we're going to go back and just kind of reiterate what we did with wiki. So I'm just going to hit clear, refresh, and so we just have our session with wiki again. So that works just fine. Now let's do something really extreme and scary, at least for me. We're going to take IPv4 out. Now there's different ways you can do this. I'm in Windows. I'm going to use the GUI. This is the adapter menu. I think they call it change adapters. And so when you go into that for the adapter that you're on, there's a bunch of different protocols and things in here, and you can do various things with them. And we can see that IPv4 is clicked on here. And so that's good. If we go down just a tiny little bit further, yeah, v6 is on too. So, hey, it looks the way it's supposed to. Amazing. So what I'm going to do is I'm going to click this off and then put that back into action. And let's go back over here, see if we look any different. And I think we do. We still have our v6 addresses, but v4 has disappeared. Well, maybe if I do the all command, maybe that was the problem. And guess what? No, we still don't have v4s. We're v6 only. And I'm going to point one thing else out here that really isn't part of what we're doing, but something we discovered while setting up this lab is the DNS servers kind of don't look right. So when we go back to the slides, I have a little bullet there that says, show the bad DNS status. So this is bad DNS status for a couple of reasons. One is that's not a reachable address. Nalini will tell you it's not even a reachable type of address. It's a deprecated address. What is that, Nalini? Site local? Is that what that is? Help me out here.
Yes. Yeah. No, this is yeah. As I say, Mike and I, we're going to discuss this more. I believe if you guys remember way back from the beginning when we were talking about site local private addressing, site local addresses are deprecated. What that means is you're not supposed to be using that. And so, frankly, Microsoft ought not to be giving you those, because that is that is, going against the rules of the IETF. And Mike and I will now be the protocol police and report back.
Yeah, Microsoft's going to hate us. Well, they already do. That's okay. So that and that's, thank you, Nalini. That was a great explanation. And we need to research this a little more before pestering Microsoft, but we've looked at it a little, it appears that this, and I haven't done this yet, this is just theoretical information, if you will. It appears this is an issue in the Windows registry, and it can be fixed by making a modification to the registry. Now, I haven't tested that, I haven't tried that, but that's the word. So anyway, this is just the type of thing you might uncover, and that's how you would deal with it. So, but right now that just doesn't look right. So let's take this v4 only configuration. We don't have a v4 address. And let's see how that works when we. So remember, we're a v6 only host, and now we're going to go to a v4 only site. And he's thinking about it. He says waiting. So that's not good. Remember how quickly it popped up before? We just went right to wiki. I'm thinking this isn't good. He looks like he's still thinking about it, trying something. But I'm still not happy. Even if this works, it's awful slow. But well, I guess that's I got what I deserve. So you can't reach this page. Essentially, what he's telling you is that you're v6, and he's not telling you this level of detail, but we happen to know this from looking at some of our displays. That you're a v6 host. You're trying to reach a host that runs only v4, and you can't do it. So that's not a good thing. When we go back to the slides, you'll see in red letters it'll say there that this site can't be reached, and that's a pretty scary thing. And you have your users calling, and so what do we do about that? And my assertion is that we can use NAT64. So that's this use case. So we have a v6 host that needs to v6 only host that needs to hit some v4 only servers. How do we do that? And I'm suggesting that a good answer, perhaps the best answer there, is NAT64. So what does that mean? How do we do that? First off, we need to get a NAT64 DNS64 server. There's ones that are publicly available, and there's quite a few of them. When I've been testing this, I found that there are some that appear to be available or say they are that aren't always. And they're not as consistent as they should be. There's some, surprisingly, that are available but don't return all the results as accurately and completely as I wanted. So I have some issues with some of them, but I found a few that do work. And the one that I'm demoing here is one from T-Rex. And so that's what we're going to deal with right now. And so I'm going to go back here, and then we're going to go and make another protocol change. And remember, we just did that. And what we did the last time we were in there is we turned off IPv4. So let's see, is he still turned off? He still is. Well, we're v6 only, so any change I make, I'm going to have to go over to v6 and make a change to that piece of the protocol stack. So let's go in there and see what we can do. So just in general, here you have your address and you have your default gateway, and there's a few other things. The thing I'm going to mess with right now is the preferred DNS server. And what I'm going to put there is the address of the NAT64 DNS64 server that I just talked about from T-Rex. So that's not something I own. It's conceivable you could come up with your own NAT64 server, but that's way too hard. So I'm just going to use somebody else's. And so that's what we're going to do. We're going to put in, and you can find this yourself. You can use the reference material that Nalini provides, but you just have to find an address for the server that you would want to use in this case. So here comes the one that we're going to use. And Nalini's watching to make sure I type this right. I think I did. I rarely get it right on the first try, but let's see if today is a miraculous day. So, and then that's all we do. That's the only thing we're going to change. They've made it pretty simple for us. I mean, it's scary making a protocol stack change and all that, but you do it in your lab environment first, and then everything is wonderful. So let's go back to our CLI display and see if that made any changes. And lo and behold, it did. the most significant thing, our addresses are still kind of the same and everything, and there's still no IPv4, but down here we have a DNS server, and I think that's the same thing I tried to type in, and that's way different than that ugly stuff that we saw before, and I don't know, maybe it'll even work. So let's go over and see if anything is different. So all I'm doing is going back to the IE screen. I'm gonna hit refresh, and boom, it comes up immediately. So if we go back to the slides, you'll see I say in there that we attempt a session and it works, hooray. So NAT64 worked, and it really wasn't that hard to implement. So I think that's pretty much good news. And I think that's also the end of case number 2. So Nalini, I'm gonna do another big pause, see if we have any questions.
We do, and this one came in, gosh, I think it was in the very, very beginning. And so, and you know what, is like maybe the gentleman can tell me exactly which that question it was, because now I'm getting kind of lost in all these commands. I hope you can.
Oh, well, that makes 2 of us. I'm lost too, but we'll get through this together.
Yeah. No, that's, I have to go back and look. But what he was saying is that there might be times when you don't have enough IPv4 addresses in the pool. So some of what you're talking about might be real common. And so if the gentleman who put that message up, if he can tell me exactly which command, if he remembers that he was thinking about, that'll be great. And then we can discuss that.
Yeah. Yeah, let me take a guess at what he meant. And if it's not what he meant, it's a good point anyway, is that I said, you know, do we really want to be IPv6 only? And one of the reasons that I didn't say, and I should have, is that you might be running out of addresses. So you might need to be IPv6 only. Now, most of us have conquered that with things like NAT and private addressing, which all that stuff I don't think is good. So I like whoever, if that was their point, I like their point and I agree with it.
Yeah, definitely not everybody is in that situation. Some people have plenty or they're using NAT, but yeah, sure, great. Alrighty, that sounds real good then. That's the only question we.
Okay, so should we plot on to case number 3?
Sure. And actually I've heard back from the gentleman and he said, yes, exactly. That was his point exactly, is that if you don't have enough IPv6 addresses, then then you're going to use v6 only. Great. I mean, might as well. So, okay, great. Good. All right. So let's go forth, and maybe you want to go through. As I say, you did a heck of a lot of commands, you know, and so it might be good to just kind of go over them again, just real quickly, you know, for everybody.
Okay. Now, do we want to do that now or do the third case first? The third case is different, so I kind of like doing it now.
Oh, okay. All right. Yeah, just do it real quick.
The third case is security, so the commands and everything's going to be a bit different. So if we do these now, so this is just, we're going to reiterate what we just did. What we wanted to do is we first want to go through and see that the host was dual stack, and we used IPv config to do that. Then we established a session to a remote IPv6 or dual stack server that happened to be google.com. We then went back to our CLI and did that horrible command that showed all the addresses and ports that were connected, and indeed it was working, and Google was out there. We then shut down the Chrome session, went back to the CLI and did the netstat again, and saw all those sessions were gone. All those IPv6 sessions were gone. Our next goal was to find an IPv4 only server. We did an NS lookup for wiki.com, found that wiki.com was IPv6 only, and it was an IP address that was 66.96, I think 149.1. And we went to an IE screen and established a session there. And then it worked, and it worked just fine. Then we went back to our little CLI screen, and we did another netstat, and we saw a session with a 66.96 address. And so everything is working, and everything was working the way it was supposed to. And once again, I'll reiterate that all the sessions we saw were either V6 to V6 or V4 to V4. They just can't talk to each other, and that's part of why why coexistence is such an important challenge for us. And I think that was all that that we did. Okay, so case 2. In case 2, we have an IPv6 only host for various reasons. Like the person with the good question said, it could have been addresses, but whatever. I mean, we have IPv6 only hosts, and so what can we do when they need to have a session with an IPv4 only server, which probably won't work. Well, we kind of know it won't, but that's what we showed. So number 1, we showed that we were a dual stack host. We went to wiki.com again. That worked. So then we went into the protocol stack definition in the Windows GUI, and we turned off IPv4 on that host. We went back and looked at IPvconfig and IPvconfig all to see that the configuration had indeed changed, that v4 wasn't out there. As a side note, and not to confuse anyone, that we had that weird DNS status that Nalini's going to fix for us. And so then, but then the important thing that we did is we went back to that IE session and tried to go to wiki.com, and it sat there and it tried and it labored, and you could see steam coming out of your laptop. But we finally got this this message that said the site couldn't be reached. And so we were somewhat in a panic, like, what should we do? How are we going to fix this for all of our user population that's v6 only? And Nalini, I think you can go to the next page now. Thank you. And so what we needed to do, we decided, was to implement some transition technology, and the preferred one here, we think, is NAT64. So we talked about, that we need to find a NAT64 server, and we looked for a few of them. And our favorite one to use, for at least for right now, for me, and your mileage may vary, you may make different decisions. Doesn't matter as long as it works. I went to one that's hosted by T-Rex, and here was the IPv6 address of that NAT64 server. So we went into the Windows GUI and we plugged that into the v6 part of the stack definition there. And in particular, we plugged that in as the preferred DNS address. And so then we went back to the CLI. We showed that the DNS status looked a little better. We immediately went over and tried to do a web session with Wiki, and boom, it worked immediately. So we were all very happy, and so hooray, we're celebrating. And I think that's it for the first 2 case studies.
Yeah, there's one question which is interesting, and it's good to take that one right when we're in the middle of this. The point that the gentleman was making is that this public DNS is all well and good, excuse me, for public addresses, but you're gonna have DNS addresses which are inside your own network, on your intranet, if you will. Yeah, you want to talk about that?
Yeah, I do. That sounds like a real enterprise guy after me own heart here. And the reason is that there's several, I'm going to say, consternations with using this. One is, so we at enterprises, tech support people, what's drummed into our head is do not impact production. Everything's got to be reliable, available, etc. And I don't have enough experience with any of these NAT64, DNS64 servers to know that they are, and that I could feel comfortable introducing them into my production network. I mean, I don't know that that's going to be a problem. I just don't know enough to say that. So do we need something internal which would solve, the person that asked the question would solve that issue too? It's conceivable that we could advertise our internal addresses to the public DNS 64 server. So there's ways to skin that cat, but it is absolutely a great point that whoever asked that made.
Great. Let's go to the next session then. Yeah.
All right, on to security. So we get to have some real fun here. So arguably, and I'm not a security person, but for some of the things that our group does, we have to implement it. And sometimes we have to do the rules. It depends on the platform. and there's a lot more security devices than just the firewall, but we're going to focus on the firewall today. And a lot of this will apply to other devices because you're basically out there trying to protect things, and you're protecting things a lot of times at the IP layer. So that's what we're doing. The biggest thing I can say is that, you know, we know there's going to be lots and lots of rules, and a lot of people will say, well, how many more do I need for IPv6? And I'm going to say at least doubled, because you kind of need to accommodate. I mean, you can have a rule that's TCP only, and that should apply to both. But most of your rules involve IP to some degree, and so you're going to have separate ones for v4 and v6. Again, they don't talk to each other; they're separate. They have to be managed separately, which, you know, maybe is going to drive us crazy. But you know, it's just something we have to get used to, and you just kind of double it. Now, there's going to also be some new and unique IPv6 rules, so it's going to be at least double, and maybe a lot more. And we're adding more. I had somebody tell me this the other day. We're adding more just with v4 every day. It just gets to be more and more, and then we implement, you know, things like microsegmentation, and there's just more and more firewalls. There just seems to be the need for more and more rules and more granular rules, and so it's not going to get any better. So I think it's important that we at least try to understand it. So Nalini, I think if we want to do the live stuff, you need to make me presenter again, and we can give that a try.
1 minute.
Okay. All right, I got it. And okay, so just as a warning, here's what I am trying to do. I'm trying to show some firewall fundamentals, and what we're looking at here is the Windows firewall. A lot of the firewalls and the rules and things are very similar, but just know that, you know, it'll be different on checkpoint, or it'll be different on, you know, the Linux IP tables is going to be very similar to what we're doing here in the Windows firewall, but different. So if this is really important, we can do another session with other firewall platforms, but for now we're doing Windows, and we're doing Windows CLI. And so I think it's a good representative look at what we're trying to do. But one thing, again, that I get asked a lot is, well, how many rules? And so that's a good thing that you want to know. So, like, here's an example of a command. And by the way, I think we use this command in some of the other sessions. The netsh command has a lot of sub definitions, and you can use that to dig down and to get a lot of the protocol information for both v4 and v6, and into TCP and UDP and a few other things. So, you know, it's one that I didn't use much before, and now that I've discovered it, it's actually a pretty handy thing. And there's some ways that it's better than using the GUI. There's sometimes you can use something in netsh where you don't need to reboot, and so that's always really helpful. But anyway, I digress. So here's an example of, I'm going to look at how many rules do I have out there. So I'm looking through that, and so look at all those rules, and those are the names of the rules. That's something you might want to do just to get a feel for not only how many rules are out there, but what your rule names are sometimes pretty self-explanatory. They let you know what that rule is probably doing. At least you'll have the surface indicator, and then you can look at the details of that rule if you want. Let's see, I also want to do, that's not going to do it. This is a similar command, and by the way, the big thing I'm doing differently here is find versus find string, and all I'm doing here is let's pretend I just did that display, and all those rules rolled by, and I go, well, I kind of have a feel for how many I've got and what some of them are, and I can look at that. But how many do I really have? And so all this does is count the number of rule names that I have out there, and it's 314. So that sounds like a lot, but it really isn't. This is just a dumb little test lab server, and you'll have many times that in your production networks. You know, thousands or even tens of thousands, and I'm sure there's implementations where there's even more. So it can get kind of scary, and that's why we want to do this and kind of understand it. So that lets you know what you've got out there, at least at a high level. Now you can see all these rules have rule names, and so what we want to do is, and this is kind of like a Mike opinion, is I think as you add rules, you want to come up with something that would be sort of an indicator of what your rules are doing. And I don't think you should reinvent the wheel. So you got hundreds or thousands of IPv4 rules already out there. I would leave those alone in terms of their name and just assume that if it doesn't say v6 in it somewhere, that it's probably a v4 rule if you're doing something that's rule name based. But when you add new v6 rules, I think it's probably a good idea to add something to the name that says IPv6. So that's what I've done. You don't need to do exactly that. You don't even need to do that at all. But so this is just a little look at some of the, I'm saying, give me all the rules that have the string IPv6 in them. And you can see the first few here. Lost my cursor. The first few here are ones that I have added, and they have IPv6 in them. So these do too, but these are core networking rules, and we're actually going to talk about those in just a minute. But that's a difference between ones that we might have added ourselves that are custom to our network and important to us for various reasons, or things that are just natively part of the stack or product that we're dealing with in this case. So that's to me the value of a naming convention, and I think it's one that you want to exploit in your own network. Not necessarily doing exactly what I did, do what's meaningful in your network, but I think having that naming convention is somewhat self-documenting and helps us survive and manage these challenges that we have. I'm going to do one more similar command, and I'm going to take the IP out of the v6, because what will happen then, I think, is I'll get a few more, and a lot of the core networking rules just have v6 in there one place or another. So I can find a lot of those in addition to the ones that I added. And now I know I have a little bit better perspective on how many IPv6 specific rules are out there. And again, looking at the name, because they kind of describe themselves reasonably well, what they're probably doing to me or for me. So this could be a pause. Nalini, up to you. Otherwise, I'm going to go on and do ranges of rules.
No, yeah, let's go on, because I'm not getting any more questions in this area. So
it must be crystal clear, or we've put everybody to sleep. So I'm in v4, we only typically have one address per platform, and that was pretty easy. In v6, you can have multiple of them. We've already seen that. And you can even have ranges of them. You can have addresses that change. So sometimes you need to do a range of addresses in your rules. It's something that you might have done in v4 because you wanted to accommodate a subnet situation or a DHCP range, things like that. So it's not entirely new, but it sure is a whole lot bigger. We're going to take a look at one right now, and here's a range that's an entire /64, which is quintillions of addresses, and that sounds a bit outlandish, but your ISP may grant you that, or it may float within that range, or there's a bunch of other different situations where that might be something that you need to accommodate. This is pretty extreme, but this is actually a real life one that we needed to do, and you can see here. And well, it'll be clear when we go back to the slides that there's a dash there. So everything in this /64 all the way up to FFF in that same /64 is going to be accommodated by this particular rule. So keep ranges in mind. Is somewhat relatively new, but it's very manageable, and all the firewalls products that I've looked at handle it nicely. And even as large as this seems, it doesn't seem to be a problem in any way. They just have some real efficient regexes that process these statements when they come in. So that's it on the rule ranges, or rules that use ranges is what I should actually say. I'm going to say one more thing that I don't think I have a command for, and that's that most of your rules are going to be trying to control what comes into your network. In other words, this range of IPs or this IP can come in and access this server. But a lot of times you need to control it by the server and maybe even the port of the server. So if the server address changes, and this is much more prevalent than IPv6 than v4, because of some of the new addressing technologies that we talked about at a previous session. So you have the security and privacy addresses that are the biggest area that you need to be concerned about, I think, because most of the stacks will default to using those, and you set up a rule in hour one, and 3 or 4 hours later, that address changes and your rule isn't working, and you're wondering why. But DHCP ranges can create the same situation. And then we have Slack, which is the new automated way of assigning addresses in IPv6. So there's some new situations here where the addresses can change. If that's impacting you in a way that makes it difficult to code firewall rules or anything else for, you might want to consider using static addresses. And that's what we classically do on the servers for the most part today anyway. And I think it's still a good idea. If there's security issues, then there's ways that you can handle this. It's just more difficult and complicated. So just be aware that that's out there and that that's something you may need to contend with. I promised that I would talk about core rules. And again, core rules are ones that are already there. The product provided them. And let's see if I can give you an example of one. No, I can't. I got one here somewhere, I'm sure. Okay, I'm going to show one. So let's say that, and we still have this address, or rule name display up at the top of our screen. There's a whole bunch of names up there, and I'm going to pick one, and I'm going to pick one called router advertisement for ICMP in, because that sounds really interesting to me. So let's look at what that is. And so this is something that I didn't do. This was part of the product, but let's see if we can figure out what it's trying to do. First off, it's called router advertisement. And from Nalini's past sessions, we kind of know what that is. And so we know it's pretty important too. But let's look and we're actually looking at the rule now and the definition of what it's going to try to do or prevent people from doing. And it's an inbound rule. It goes across all the profiles, and it's in the core networking. So, it's not my fault. I didn't do it. Any IP address on the local system here is going to apply. This rule is going to apply to. But now let's get into the guts of what's really different about that rule. All that other stuff is important, but you're going to see that in every rule, and it's not going to vary a whole lot. But so here's the remote IP has to be an FAE80 address, and it's using the ICMP protocol. And then there's some type stuff here too. So what's all that telling us? What this is telling us is that, okay, if this is a router advertisement, I only want to get it from something that's on my local link. In other words, this is FE80, as we remember from some of Nalini's past sessions, is a link local address. The only things that are on the local subnet or local link with me will I accept a router advertisement from. Further, it needs to be ICMP. And then here's where we really determine what it is in terms of being a router advertisement or not, because a router advertisement is something that it's an ICMP packet. And if we look at it a little further down, and we actually did in a trace that we did in a previous lab, if it's type 134, then that is a router advertisement. So the sum total is, if some rogue router tries to send me a router advertisement and change my address or whatever nefarious thing he's trying to do, and he's not on my local network and he's coming to me from the internet or maybe from another adjacent network in my organization, I ain't going to accept it. I ain't even going to let it in. I'm not going to let it process. So only if it's all these things will I allow it. So that's I probably went a little too far on that one, but that's a core example, and I think that's a good example of one that, and it shows what type of control you're trying to put on some of these things that can happen in your network in IPv6. I think it's important and good to know. And Nalini, I think that is it. Oh, do we have? I'm going to do one more real quick thing here and then wrap up. I have 5 whole minutes. All the stuff I showed you was Windows CLI. Almost all your platforms, whether it's Checkpoint or anything else, you will frequently also have a GUI. Here's the GUI of the Windows firewall. It's going to be the same stuff, only presented in a different fashion. So just know that I'm not going to cover that or do anything with that. Just know that it's out there. So if y'all like GUI better than CLI, I'm kind of a CLI guy. I'm sorry, but you have your pick, so you get to choose. I think that's all. Nalini, you can go back and do the slides again, and we'll wrap up with conclusions and then questions.
Sounds great.
All right. Let's see if you go like a couple slides forward. I'm going to start saying conclusions because we have some time, but not a lot. This is really important stuff. So as we start to do IPv6, the transition steps and technologies, we need to think about these and plan it out. If we do, it's going to go well. All the stuff we did is very doable. Nalini taught me to do it in what? 2 days, and you guys will learn in 2 hours. But an important factor is that IPv4 is not going away anytime soon. So managing this coexistence is going to be really important if we want to succeed, and obviously we do. Stating this again, the best transition technologies that we're going to want to use will be dependent on the use cases, and we saw that. We did different things for different use cases. Many more use cases are going to exist, and we just don't have time to address that today, but as you start looking at what yours are, then you'll see, and then you'll decide what the better technology is to deal with that. And Nalini's always there to help with that. I'm offering you up for everything. And then for the security platforms, they're going to be even more important. They're going to be more complex, so we need to understand that. But they're understandable. They're doable. They're supporting this well. And so we have a good fighting chance to be successful there too. And then Nalini, I think we just have one more slide. And I think that's that we just want to, so we've covered as much as we can, I think, in an hour. There's more out there. If you want details on some of these transition technologies or what to do with them or the deployment of IPv6, look at some of these drafts. Both of those are really, really good. And there's more documents out there on the V6 Ops Working Group at IETF. So feel free to do that and then ask us even more questions. And I think that is it from me. And I'll turn it back over to Nalini. Thank you so much for your time and attention. And any questions, let them rip.
Yeah, so we've got one question. So he wants to go back to case 2 second slide. So let me do that. Okay, case 2. Okay, case 2 second slide. Yeah. I think the question is, maybe it was okay, so hang on for a second. Whoever, yes, okay, oh, sorry, case 3. Case 3. Yeah, you know what? And so what I'm going to do is I'm going to unmute the gentleman and say, okay, so I have unmuted you. And so if you want to talk about what your question is, then that would be great. So just, do you want us to explain it again? Yeah, case 3 second slide. Yeah, you know, I will say these firewall rules are yeah, you have to mute your thing if you want to talk. Yeah, he just wanted to see. Okay, we will be sending. Okay, great. We will be sending this, and you know, one of the things is like, oh gosh, there's so much to do. See, okay, like for example, like firewall rules for IPv6 are really important, because you can get some smart aleck who's like, hey, Keith, I'm to do ping to, you know, everybody in my entire site. Really, do you want to allow that kind of thing past the LAN? You know what I mean? Because that's a multicast address. You know, I can do this multicast scope. So, you know, you want to be real careful. And depending on how you do your VMs, I mean, as I say, Mike and I, we have done some seriously interesting things. If you don't disallow multicast pings in a virtual environment, I'm hoping we'll get some chance to discuss some of that. So I guess one thing I'm going to say is like this year is just kind of the basics, but we're gonna keep going. We may not do as many in the next year, but maybe once per month, something like that, instead of 2, sometimes 3 or 4 per month. We'll definitely keep going, and we'll get into more advanced topics. So you know, just and as you guys you know, do your implementation or wherever you're at, if you have questions, please send them, and people already do, which is really good. And we will be sending the recording as well as all the foils. Thank you very, very much, Mike. It was just great. I love how you do your style, and I know everybody else does too. Thank you for all your work. Thank you, everybody, for joining, and we're going to send everything out. So good luck with implementation. I'd love to hear about successes.
Thank you, everybody. Have a great rest of the day.